Let us discuss about the behavior of the capacitor in an AC. Here we have E is equal to E0 sine of omega t, and we know that when we connect a capacitor on a supply, the current flowing in the circuit charges the capacitor. And let the charge on the capacitor be equal to, or the charge deposited on the capacitor be equal to Q. From the study of the capacitance, we have Q is equal to CV, where C is the capacitance of the capacitor and V is the voltage. So here we have Q is equal to C into E, that is equal to C into E0 sine of omega t. Now, in order to have a relation between the current and the EMF, we have to change this charge to current. So we have to differentiate this charge versus time, so we will get the current. So I will be equal to dq divided by dt, that is equal to d by dt of CE0 sine of omega t. Now, I is equal to CE0 being constant is taken out of the differential sign d by dt of sine of omega t, and we know that differentiation of sine is cos, that is equal to CE0 cos of omega t, and internal differentiation of omega t is equal to omega. So we have I is equal to omega CE0 cos of omega t. We also have that cos of theta is equal to sine of 90 plus theta, and from that I is equal to omega c E0 sine of omega t plus pi divided by 2, where pi divided by 2 is 90. Now we can have this equal to I is equal to E0 divided by 1 by omega c. If omega c comes to the numerator, it will be the same omega c into E0 and sine of omega t plus pi divided by 2. Looking closely at these two equations, E is equal to E0 sine omega t and I is equal to I0 1 by omega c sine of omega t plus pi by 2. This looks that it is the peak value of the current E0 divided by 1 by omega c. So we have that I0 is equal to E0 divided by 1 by omega c, where 1 by omega c is the capacitive reactance and that is equal to the XC. So we have that I0 is equal to E0 divided by XC. Now, talking of the phases, here the phase is omega t, here the phase is omega t plus pi divided by 2. That means the current in the circuit having capacitance only, or the capacitor only, leads the voltage by a phase angle of pi by 2. Here the current leads the voltage by a phase angle of pi by 2. In an inductor, current lags the voltage by a phase angle of pi by 2. But in a resistive circuit, the current and the EMF have got the same phase. That means the phase difference is equal to 0. Now let us take a look at the waveforms and the phasor diagrams. When we talk of the waveforms, here E is E0 sine omega t. That means we are having this waveform E is equal to E0 sine of omega t, as the current leads by a phase angle of pi by 2. Lead is shown by an anticlockwise angle. That means the current starts from here. So this is I is equal to I0 sine of omega t plus pi divided by 2. So this is the inner current I, the waveform of the current leads the waveform of the voltage by a phase angle of pi divided by 2. Let us take a look at the phasors. We have got this X, we have got this Y, and this is Y dash, as E0 has got an angle of omega t. So E is equal to E0 sine omega t, but the current leads the voltage. That means we have to move in an anticlockwise manner by an angle of 90 degrees. By an angle of 90 degrees with respect to the E0. So this will be equal to I0. So the current leads the voltage or the EMF by a phase angle of pi divided by 2. Here also we have that this much angle is equal to omega t. So here the current leads as the angle is anticlockwise. If you remember in the inductance, the current lags by a phase angle of 90 degrees. Thank you.